All right, class, hopefully this is working. I am trying this on the other computer. So today we're going to talk about a geometric sequence. We were doing arithmetic before where we had the difference between the terms were the same. A geometric sequence is where the ratios between consecutive terms is always the same. So recursively it's defined as if you have a spot, all you need to do is multiply by r to get from the previous term to get to the next term. And r is called the common ratio. Okay, the common ratio. Okay, a geometric sequence follows this pattern. A, then we have A times a ratio. Then we have A times a ratio squared because we have another ratio we're putting there, and so on and so forth. So then it's like A times 3 ratios to get to the fourth term. So that means that the pattern becomes A sub n is equal to the first term times r to the n minus 1. Okay? So that's what happens with arithmetic, I'm sorry, with geometric. So show that the sequence is geometric. Let's write it out. If we put a 1 in, we get 1/5 times 2 to the first. Then we have 1/5 times 2 squared. Then I have 1/5 times 2 cubed. And then I have 1/5 times 2 to the fourth. Now you guys should be able to see that this is geometric because we're multiplying by another 2 each time. So we get 2/5, 4/5, 8/5, and then 16/5. So clearly we're taking, the first term is 2/5, and then we're multiplying it by 2 each time. So my common ratio is 2 here, because that's what we're multiplying by. Determine whether the sequence is arithmetic or geometric, or neither. If it's arithmetic, give us a difference. If it's geometric, find the ratio. Alright, so this one, hopefully you guys recognize as arithmetic. It's going up by 3s. So when you're adding the same thing, remember it's arithmetic. And we would say the difference is 3. So we use D for difference for our arithmetic, and we use R for ratio for geometric. Now this one's interesting. Let's just write a couple terms out here. So when n is 1, I get 3 minus 1 is 2. When n is 2, 2 squared is 4, 12, 11. 3, we get 9 times 3 is 27, 26. This is neither, because it's not going up by the same amount with adding, and you're not multiplying by the same thing to get to the next thing. So this would be a neither. Usually when you have like the n being squared itself, that's not geometric. What is geometric is when you have a number raised to the n, like this. So this is geometric, because what happens is we have 1/2, then 1/4, then 1/8. Okay, so it's geometric. And what's happening is we're multiplying by 1/4, or 1/2 every time. 1/2 times 1/2 is 1/4, times 1/2 is 1/8. Remember, to get the ratio, if you're stuck and you don't know what the ratio is, write out a couple terms. The ratio will be the second term divided by the first term. Or the ratio is the third term divided by the second term. Either way, these both equal 1/2 when you do them. So that's how you can do that. So if you don't see what's happening here, although you should be able to see it's being divided by 3, which means it's being multiplied by 1/3. So r equals 1/3, which means, again, this is geometric. Okay, let's move on. Write a rule for the nth term. So now we're going to be using that nth term for geometric. So first thing you need is the starting point, and you need the r. So what's happening here? It's being multiplied by 3. And the first term is 5, so we can go from there and say that my nth term for a geometric is equal to the first term times the ratio to the n minus 1. When we solve for the 8th term now, we have to just plug in an 8 for n. So 3 to the 7th times 5, you get the 8th term is 10,935. All right. over here, we see, if you don't see what's happening here, 6 to 2, we're dividing by 3. 2 to 2/3, we're dividing by 3, which means we're multiplying by 1/3. And this is my first term. So I write a sub n is equal to 6 times 1/3 to the n minus 1. So that's the nth term right there. And then if you want the 8th term, we have 6 times 1/3 to the 7th. And if you type that all in and do math frac, you get the 8th term becomes 2 over 729. Okay, so that's when we have A1 and the term. Now we don't have A1. We have the 4th term is 12 and the ratio is 2. So we know that when n equals 4, that it's 12. So it's kind of like what we did with arithmetic. We use the formula, but we know that the value of 12 is equal to the first term times the ratio raised to the 4 minus 1, because n is 4. So we get 12 is equal to a times 8. So my first term, a, equals 12 over 8, which is 3/2. So then we can write the nth term is 3/2 times the ratio to the n minus 1. That's what we want. And then it says write the first 3 terms. So we have 3/2. If we multiply that by 2, we get 3. If we multiply that by 2, we get 6. So those are the first 3 terms. So you don't have to keep plugging it into the formula. You know you're just multiplying by 2 each time if you have the first one. We do the same thing over here. We know that the value is 32 when we have a first term and then a ratio of 2/3 to the 5 is n. So 5 minus 1. So we get 32 is equal to a times 2 to the 4th is 16 over 81, I believe. So you multiply by 81 over 16, you get a is equal to 162 for the first part. So that means that our nth term is 162 times the ratio to the n minus 1. And then the first 3 terms would be 162. If you multiply that by 2/3, you get down to 108, and then you get down to 72. Okay. So today we're also going to do 2 quick problems with finding the sum if it's just a finite geometric series. Finite means we have a starting and a stopping point. Okay? And to find the sum of a geometric series, all you have to know is the a and the r again, and then where you want to go to. Okay? So that's the formula here. So let's look at what we have. We need the starting point. So again, to get the starting point, put 1 in for k. So 4 times 3 to the 1 minus 1. 3 to the 0 is 1, so the a sub 1 is 4. We don't need the final one like we did for arithmetic. So we have that. You guys should be able to identify that the r here is just 3. We're multiplying by 3 every time. Okay, because that's the thing being raised to the power. And we're going up to 10. So we can now do our formula. S of 10 is equal to the first term, which is 4, times 1 minus 3 to the 10th over 1 minus 3. When you multiply that all in and evaluate, you get 118,096. And again, that is if we wrote out all 10 terms and then added them up. That's what we would get. All right. So this one here, this is 5/4 to the first, and 5. Okay, so it's just 5 is being multiplied on top. So if you guys see this, your r is equal to 5 because we're multiplying by a 5 each time, but the 4 is staying by itself. All right, so the first term is 5/4, so we know the sum of the first, this is 1, 2, 3, 8 terms, is equal to the first term times 1 minus r, which is 5, to the 8th, all over 1 minus 5. Okay, and if you type that in, you get 122,070, and that would be your sum. And again, we use this formula when it's a finite sum. Okay? All right, so that is geometric. Tomorrow we're going to just look at an infinite series where it goes on forever, and we can actually find sums of those.